Hello. Hello and welcome to this video. We are starting with functions of JavaScript. So this is going to be a very important chapter, particularly if you have not programmed in any other programming language earlier. If it is your first programming language, then it is going to be critical to understand how things work as far as programming languages in general work. So functions are present in all programming language. They are essential for programming. So the notion comes from the mathematics. So for example, in mathematics, you can have a function of x, something like 2x squared plus 3x plus 7. Okay. So you put a value of x and you get some value out of the function. There can be two variables, for example, equations of circle or even equation of a straight line. So for example, equation of a straight line goes like this, that you have x and y coordinate, flexible document, x, and the equation of function is ax plus by plus c. So you put in xy and you get an equation. You put in xy and you get a particular position on the line. So along with ABC, that is, ABC are constants here. So similarly, in programming languages, a function is a piece of code which is reusable. That is the whole idea of a function. So how a function looks like. So in JavaScript, it should start with function. And this is one of the forms of the functions, the basic one I'm talking about, not about other functions and other things, or function expressions. So we have a function and then we have a name. This f is the name of the function. So it could be alphanumeric, but cannot start with the number, and there can be underscores. Then we have parentheses. The parentheses can contain arguments, 0 or more. Here we don't have any arguments. There could be arguments, as you will see. Eventually you can see here who is there, P1, P2 are there. And then you have curly braces. These curly braces mark the body of the function. And the body of the function can have code. Okay. So this is the essential part of how a function looks like. When you have a function in a script or a program, you can call it like f followed by parentheses, and you can pass in the arguments which the function will receive. The arguments here received by the function are usable inside the function body as if they are local variables. Also, unlike some programming languages, for example C, the call to f does not necessarily require to be after the function is written. You can call it beforehand. When the function is executed, all the function definitions, we call it definition, all the function definition, that is this much code, will be hosted and put at the top of your script. So you can, when we refer to this name f, that is available to you, even if in code f is before this function body. Now functions can optionally return some value, or they may choose not to return some functions. Also, a function can call itself, which is known as recursion. So there are various types of recursion. There is normal recursion when a function calls itself. Then there is a mutual recursion when one function calls another and another calls the first one. Then we have generative recursion and all that. So there are various different forms of recursion which we will see as we progress. Now to start with the one function, we have print properties. So function is the keyword and print properties is the name of the function, and O is the name by which we are going to receive the argument. And we expect O to be an object. And we iterate over O and print the properties and the value of that property. We have created an object O here, which has three properties, X, Y, and name, with values 1, 2, and shape respectively. And then we call print properties O. So it will print X colon 1, and then on the next line we will print Y colon 2, and then in the next line it will print name colon shape. So the value of T will be X, Y, and name in three different iterations of the for loop. And O, T within square brackets will assume the value of 1, 2, and shape. So let's see this in action. Let me increase the font a bit. Node 1.get. So as expected, we have the output. Now there is something here. If a function does not explicitly return something, then it becomes undefined. So for example, suppose here if I say let return value is equal to this, and we do console.log and return value, it will be undefined. So I'll show you. So you see, it is undefined. Okay, so that is one function. The other type of function can receive more than one arguments, and optionally they will return some value. So we have two objects here, P1 and P2, both have the same property, X and Y. You can assume that they are two different points with XY coordinates. And then we call distance function with these two objects, P1 and P2. So our function here is function, the mandatory keyword with the distance name, and receives two arguments, P1 and P2. They are separated by comma. Once we have P1 and P2, we can say that let the dx, the difference between the x coordinates is P1.x minus P2.x. And we can say that dy is equal to P1.y minus P2.y. And then we can compute the square root of the dx into dx plus dy multiplied by dy. So as you know, this will be the distance formula, so it will return the distance. So here the difference with the print properties is that it is returning a value, okay, which we can store and reuse as well. The second difference is that it is receiving multiple arguments. So let's see this in difference. And we have 11.18 as the distance between the 2 points. Now let's go and look at the third function which we have. This might be confusing, but eventually it will make sense. So we have a function factorial which computes factorial of any given value. I mean positive values, and there will be limit up to how much you can go. So suppose we pass 10. Then what happens is that it receives 10, it sees that 10 is not less than 1. So it returns x into factorial x minus 1. So you see, this statement will become 10 multiplied by factorial 9. So what happens in the process table is, when memory is allocated, a stack frame is created. Let me draw a diagram for you, okay? So the stack frame will look like this, factorial 10, okay? And there will be some memory of stack allocated for it, okay? Some memory will be occupied by it, all right? And then it makes the call of factorial 9, okay? So a new stack frame will be created, and this will also occupy some memory. Okay, and this will continue. This will go on continuing, and eventually the code of F1 will be executed. Okay, and when it executes F1, what happens is it sees that X is less than equal to 1 and it returns 1. So what happens is it returns 1. So at this point, the stack unwinding will happen. Let me put here factorial 2. So factorial 2 at the end will be 2 multiplied by factorial 1. This will be the line where factorial 1 will be called. Okay. So once it returns 1, this stack frame is destroyed. And this factorial n will receive a value of 1 from the factorial 1 call. And then this becomes 2 and it will be returned. And here you will have the call of 3 multiplied by factorial 2. This is also returned, right? Returned. So this will return 2. So once it is done, this stack frame of factorial 2 will be deleted. And here it will receive a value of 2. So then 2 multiplied by 3 will become 6. And so on, it will go on unwinding on the return calls, and eventually it will compute the factorial 10, which has the statement return 10 multiplied by factorial 9. Okay. So stack unwinding will happen and it will eventually return you that value. Okay, that is the typical way this happens. So let's see how this program runs. And we have 3,628,800 as the possible value. Now you know that the integers are quite limited in JavaScript. That is, it does not represent infinite range. So for example, even giving 25 will cause problem. Okay, let's see this. And you see the problem. It is no longer an integer. So if you give a value of say 60, you will see the problem. Okay, it becomes 81. So this is going into floating point representation, because integers internally in JavaScript is a double. Okay, so it cannot give you the integer value, unlike Python program. In Python, the range of int is unlimited. As much as your memory allows, you can have the range. Okay, but you see that JavaScript does not have. Big integer is there, but we are not yet going to use it. So now, as you saw, that it goes on creating stack frames. So recursively creating stack frames mean that if the value of, or rather the recursion depth, that is what it is called. If the depth of recursion is too high, then the stack overflow will happen. Some languages employ the technique called tail call optimization or tail recursion to avoid this problem. But as far as I know, JavaScript does not do tail call optimization. I'll give you the factual information in the next video about tail call optimization. And we will talk more about tail call optimization probably in the next video with another example. So I'll come back to this. But as far as I remember, JavaScript does not have tail call optimization, which makes deep recursion problematic. Why we should do recursion here? What is the use of calling factorial with x minus 1? Well, the main user of recursion is reuse of the code, as we saw. The nature of the function is that you reuse the code. So the recursion further enhances that, or rather, recursion amplifies that particular benefit of a function. The second advantage of recursion is that code can become very elegant. You can implement any recursive code with the help of a stack. Okay, you can do iterative version of any recursive program by using a stack. I will show you Ackermann function in the next video probably, that how you can use that. For example, in this video, in this program, you can say let y is equal to 1, okay? And you can substitute simply for let y is equal to 1, or rather call it factorial. Sorry. So we call it factorial, okay? E is equal to fact. And let y is equal to 1, semicolon, y less than equal to x, semicolon, y plus plus. And then you do here this thing. We do fact multiply with equal to y into fact. And eventually we do fact. Okay. So it was a simple program and we did not need stack. But in general, you can implement any recursion with a stack. As I showed you in the stack diagram, you can simulate the stack yourself. So that is about recursion, and we'll talk more about recursion in tomorrow's video, or rather the next video of JavaScript functions. Functions will take probably maybe 5-6 videos. It's a good topic. Then we have function expressions. Now, one rule here is that function expressions are not hosted. So in JavaScript, I'll explain what is function expression first, and then I will talk about hosting. So in JavaScript, functions are first-class objects. Many languages do that. Some languages do not have this feature. So, for example, you can assign the function to a variable, and the value of this variable will be the function itself. And once we have declared that variable, we can call that variable with that name. Now, this is the function expression. Note that the name of function can be omitted here. Okay, it is optional. As you can see in the next example, fact is used here so that we can call it. If you don't give a name, you won't be able to call it, but it is optional. Okay. The other thing is that you can pass this as an argument. So here function AB is an argument here. Okay. And this can be invoked as well. Right. So if you want to invoke it, you can invoke it like this. Say 5, then it will give you 5 squared. It will give you 25. Okay. Now the invocations I have shown is square 5, and we have fact 10 or const f 10, and we have this example. Now when you use this kind of expression, function expression, and assign it to a variable, make sure that you name it, or rather qualify it with a const qualifier. The reason is so that you don't accidentally overwrite the square value. That might cause a bit of problem. Now we're talking about hosting. So square variable is here. This function won't be hosted, so you can't write this console X before this code. Won't work. Okay. If you want to see, I can show you. Cannot access square before initialization. So it must be after this. Okay. Normal functions are hosted, but function expression cannot be. So now you know the sorting also. This function we have already seen, so it prints 1, 2, 3. Now, one more thing I wanted to talk about is that before ES6, functions could be written only at the top level or the outermost level of a program or within a function. But starting from ES6, the function can be at any block level. And it will, by block level, we usually mean in the languages by parenthesis, or in Python an indentation level. So any function declared in a block will live through that block. Of course, you can return the function because essentially it's a variable. So you can return a variable to outer levels also. But usually it will live for the duration of the block. This is a change from ES6. So I think I'll stop here because we talked about a lot of things and it might be difficult to hold a lot of information. So in the next video, we will talk more about recursion and tail call optimization. And I will clarify exactly whether tail recursion is allowed in JavaScript or not. And I'm ending this video here. And I hope that you find this video useful and informative. So we will meet again, say after 4 days, with another video on functions of JavaScript. So thanks a lot for watching the video and enjoy.